today we're going to talk about what are called permutations and combinations. And then we're also going to use something called the fundamental counting principle, which is going to help you answer awesome questions like, if I have 6 shirts, 3 pants, and 2 necklaces, how many outfits can be made from those? So that's what we're going to talk about first, okay? And this is going to be the fundamental counting principle. So how many outfits can be made? So one way that you can think about this, okay, is if you, and this means that you have to have a combination of one of the shirts, one of the pants, one of the necklaces. So if you have 6 shirts, I'm just going to write 1 through 6. These each represent 1 shirt, okay? What a beautiful shirt. Okay? And then, no, because we're just going to look at the first one. So with 1 shirt, you have how many pant options? 3. So 1, 2, 3. Those are all your pants. Then you have 2 necklace options. So if you choose this shirt and this pair of pants, okay, and then you have 2 necklace options. 1, 2. And make a beautiful necklace. Maybe a beautiful diamond or 1. Okay? And then you did that for every single one. For the first shirt, how many options would you have? 6. So 1, 2, 3, 4, 5, 6. Okay, so 6 options. Now, if I did that for 2, 3, 4, 5, 6, how many options would you have for each? 36. Yeah, 36 altogether. Yeah, so 6 options for each one. 6 times 6 would be 36. Another way that you could do this, instead of drawing this out and calculating that, is you can use what's called the fundamental counting principle. And the fundamental counting principle means that you can multiply 3 times 6 times 2, because 6 times 3 is 18. 18 times 2 is 36. So there are 36. This row seems closer. Okay, so you can multiply those together. 3 times 2 times 6. Okay, so we're going to use the same principle to do example 1. So you are making a frozen yogurt sundae for $2.99, which is a steal of a deal. And then you can choose 1 flavor of yogurt, 1 syrup, and 1 topping. How many sundae choices are there? Okay, so you can choose 1 of each of these. And then this chart is going to give you the options. Yeah?
Why does the price matter?
It doesn't. I was getting happy. Okay, so to make frozen yogurt sundae for $2.99, you can choose 1 flavor of yogurt. So how many yogurt flavors are there? There are 3. Right? Chocolate, vanilla, strawberry. And then how many syrup choices are there? 4. And then how many toppings? 4. Hey, guys, stop throwing stuff at each other. This isn't middle school. 3 times 4 is 12. 12 times 4 is 48. So there are 48 different sundae choices. Now all of them are delicious per se, but there are 48 sundaes. Yeah, they are choices. Okay? So a password for a site consists of 4 digits followed by 2 letters. And the letters A and Z are not used. Each digit or letter may be used more than once. We have to find how many unique passwords there are. And unique just means different. So how many different passwords are possible? So let's talk about the options first. In terms of digits, do we know how many digits there are? No. I think you're thinking of letters. Yeah, why are there 10? Okay, So then why'd you say 9? Yeah, so that's the tricky part, is yeah, you can have 0. And then, all right, how many letters are in the alphabet?
26.
Yeah.
24.
So in the alphabet, 26 letters. If you can't use A and Z,
Oh, yeah.
so in this case, it'll be 24. The reason why we're writing that out is because there are going to be some where you can use A and Z. It just depends on what they tell you, what your options are. Okay? So what we're going to do is we're going to set this up. The digits are going to have 4 spaces, and then the letters are going to have 2 spaces. And I just like to say, okay, here are my letters, and then I have 4 spaces for the digits, and they can be used more than once. So how many options do I have for the first digit? 10. And then for the second digit, 10. So remember, we're multiplying, we're using the fundamental counting principle. So 10 options here, 10 options here. For the letters, how many digits? 24. And again, it's 24 for this one only because you can't use A and Z.
Oh.
And then they can be used more than once. So now we're going to multiply. This is going to tell you how many possible password combinations you have. Now, if I'm entering this in my calculator, I would do 10 to the 4th power, and then multiply that by 24 squared. Just be a little bit quicker. And you guys can use your calculators. Okay, and then, what number is this?
576,000.
Yeah, 5,760,000. Okay, so lots of different combinations, even just with those. Okay, that's how many passwords. Okay, so just seeing the number of passwords too. You guys have probably entered passwords in sites where they're like, oh, you have to have this, you have to include this. That just makes it more secure as you have more options. Now, this is what if you couldn't repeat digits or letters? Then how many would be possible? Yeah, do you know how to set it up?
Wouldn't it just be 10 times 9 times 8 times 7 times 24 times 23?
Yeah, so if you can't repeat them, the first one you have the option of 10 digits, but once you've used one, now you only have 9 options. Then you've used 2 of them, so you only have 8, and then 7. And then for the letters, the first one you have all 24 choices, and then you have how many? 23. Okay, so we can multiply these together. So 10 times 9 times 8, divided by, times 7, times 24, times 23. Do you guys think there's going to be more or less? Less. Okay, so less options for the digits and the letters when you can't repeat them means less overall. About how many less would you say? Yeah, approximately 3 million, right? Because this is 2,782,080, right? So this is like 2.7, that's about 5.7. Okay, great. All right, the next thing we're going to talk about is something called a factorial. So a factorial is the product, which product means you do what? Multiply. So product of the natural numbers. Do you guys know what the natural numbers are? Yeah, the counting numbers. 1, 2, 3, 4, 5. Okay, so start at 1 and then goes up. And then it's less than or equal to the number. Okay? So the symbol for a factorial is an exclamation point. That's a factorial. And so if you see for factorial, what that means is 4 times 3 times 2 times 1. Now this you can do without a calculator, because 4 times 3 is 12, 12 times 2, 24. Okay, and then try 6 factorial. So I want you to write out what that's going to be. Right, because if you're multiplying by 1, you get the same thing. Okay, so write it out. 6 times 5 times 4 times 3 times 2 times
Are
1.
we gonna have to memorize this? Like you have to memorize like the multiplication even though you have to memorize factorial?
No, because you can just multiply them all. Okay. All right. So those are the factorials. So one thing we're going to do with factorials is evaluate. Now some of these you can do without your calculator, and it's quicker to do. Okay. So if you have 3 factorial, it's like 3 times 2 times 1, and then 2 factorial is 2 times 1. So instead of calculating these out, cancel. 2 divided by 2 cancels, 1 divided by 1 cancels, so you're just left with 3. Yeah, it's possible. Do you remember doing it in middle school?
My 10-year-old sister came home talking about factorials.
Oh.
And I don't know why.
She has a break.
Yeah, I wonder if they do that. Okay. That's okay. It's okay if it's new. And then, so when you're trying to cancel things out, when I look at 9 factorial and I see I have 6 factorial on the bottom, what I'm thinking is when I rewrite the 9 factorial is 9 times 8 times 7 times 6 factorial, right? 6 times 5 times 4 times 3 times 2 times 1. So instead of writing all of that out, I can stop there. Now I still need the 2 factorial, right? But the reason why I would want to write it like that is so I can automatically cancel these out using logic. Because then all I have to do is 9 times 8 times 7 times 2 times 1. But again, the times 1 is just going to be itself. So when you're doing that calculation, you could just do 9 times 8 times 7 times 2. Okay, and then you get 1,008. Yeah. It really is. Okay, and then this one is 5 factorial over 4 factorial. 6 minus 2 is 4 factorial. So with this, the factorial, you don't distribute it. You have to do what is inside the parentheses first. And then once you have the 4 factorials, those are going to cancel. And I'm going to show you a shortcut for how to do the factorial. Okay? So there is a very special secret section in your calculator. All right, so first we're going to type in 5. Yeah, it's under the, you guys said you know where it is? Yeah, go to math and then, no, that's fraction. Okay, so we're going to go look at the heading. So it's math, and then you have, this is number. I don't know what this is, and it's driving me nuts, so I'm going to find out what that means. But then the PRB stands for probability. And then look, here's the exclamation point. Okay, so you go to math, arrow over to probability.
I only have tested out the conditions. Oh, this is a factorial function. Oh, is it the exclamation point? Oh, yeah.
Yeah, it's the exclamation point, yeah.
Okay, I need some help.
Okay, so math, arrow over, and then here. Did you press second?
Oh, I pressed that.
Yeah, just press the math button. So go ahead and do. So go ahead and do B. Oh, yes, it does. Thank then you are going to use the exclamation point like I showed you. Well, I bet that.
I feel like that'd be easier for big
Over.
numbers. What, 5? Is that the-
Look, you couldn't even do it with 120. Gives you an overflow. The number's too large. It'd be 120 factorial. All right, so for D, it's 7 factorial minus 4 factorial. This is different than the parentheses. Okay, so if I do 7 factorial, go back to math. Okay, so this would be 50, 40 minus 4 factorial. Sometimes it really is just quicker to do the 4 times 3 times 2, and that's fine. And then this would be 1 factorial. Okay, and then 1 factorial is just 1. Here, we can show you. And then one thing we also want to write down is something special after we finish this. So that is just 1, so you'll get 5,016. Subtract. What do you guys think 0 factorial is without calculating it?
It'd be 1.
It's one of the two things you said.
Error. 0.
Oh, you guys said 0 and you said 1. It's one of those.
I think it's 1.
All right, moment of truth. Yeah, so a few things. So the first thing is, it is the counting number. Okay, so it is going to be the 1, but another reason, yeah, so this one is absolutely special. So whenever you are multiplying with a product, okay, if you multiply something by 0, what happens to it? It would be 0. So it would completely destroy the value. So this is a special case. If you're multiplying and you multiply by 1, do you change the value? No. Okay, so this is similar to, like, if we were doing 2 to the 0 power. Remember how anything to the 0 power is 1? Okay, so that when you multiply, you get the same thing. It doesn't change the value. This has a similar property to it.
But that doesn't make sense.
It's a multiplicative identity, so when you multiply something by 1, you get the same thing. Okay, so it is a special case. A lot of times with 0 and 1, you do have special cases. All right, let's try the back. So this is where we're going to identify what a permutation is and what a combination is. So we have something called permutations and then something called